What you have here is a contactor, and this contactor is used to switch power for motors. I also have a set of wires like this. I also have a bulb holder. This is how it's actually connected. I also have a light source for illustration. We are gonna use this to illustrate our load, that is to simulate the motor. I also have 240 volts supply. We can confirm that from our light here. You can actually see that's 240. This contactor is rated 240 volts coil. Remember, we had a lesson and we said we are going to demonstrate how this thing works. So I will use these two wires to connect power. So if I connect these two to my coil here, this switch should go on or engage. And so let's see that. So I have my A1. I can connect my one wire there like that, and make sure it's tight. Make sure when you are making connection, the copper is held by the screw itself. Then our next wire to come inside there. That is A1, A2. It doesn't matter which polarity you connect to, provided you match the voltage as rated. So you tighten that one too. Make sure it's gripped by the screw grip. So let's see what happens to this contactor when I put the 240 volts to it. So here we go, guys, a moment of truth. Oops, you see, it's engaging. It's engaging, so that means my contactor is fine. So that means when I put it on like this power here, it will now connect down here. You can actually take a meter to test that. This is my multimeter. I will put it in continuity mode. We can test our continuity. It's fine. So this pole and this pole should be connected. Let's see. Pole 1 and pole 2. Pole 2, you can see it's connected. Pole 3 and pole 4. We have a hinge there, guys, but they should actually be connected. Let's see which else is connected. You can see there is connection. Let's try to tighten these screws here for better contact. Remember, when you supply the coil, the main terminals do not have voltage, so nothing to fear at this point. Yeah, so you can see my poles are connected now. Yeah, let's tighten this one. The reason why I'm not afraid is because the coil is very independent from the main power terminals or the main poles. Remember, contactor is on so far. We are testing the continuity of these terminals. That is line 1, 2, 3, 4, 5, 6. Line 1 is okay, line 1, 2 is fine. See from this angle. Line 1, 2 is fine. Line 2, 3 is good. Line 3, 4 is good. 4, 5, 6 is good. But we also have this hold on coil. It's also normally open, but it should now be closed also. Let's tighten. I should be having a reading here. Okay, I hope we have pole 1, 2, 3, 4, 5, 6, 13, 14. These poles are actually contacted by this electromagnetic switch here. So by applying 240 volts, basically I wanted to mean that is how we switch our contactor. Now I'm going to connect my bulb and simulate this power. Remember, this is our input, output. Then hold on coil 13, 14. Remember, this is AC, polarity does not matter too much. Provided you maintain the sequence during your wiring and connection. You can go to my page, guys, like Facebook, like, follow, comment there, and share YouTube, Hood Engineering Solutions, and even TikTok. We have live lessons on TikTok and Facebook and YouTube too, so you can follow, join, get the knowledge. So after connecting my load, guys, I'm now going to connect my supply. Remember, you have to match, and I have used line 4 and 6, so they coincide with line 3 and 5. I have not used line 2 and 1 because I cannot see any connection on my meter because the gadget is old. I think the line is worn out, but it's okay. So all I do, guys, is bring another set of wire. See, then I will connect it to line 3 and 5 like this. Make sure the conductor is pressed by the connection, the screw plate that should hold it. There you go. Our conductors are now connected. So now I strip the other side. Remember, supplying power here in these two terminals, we need 240 so that we can switch on our light here. This coil is also 240, so it means these two wires can be joined together like this in parallel to share 240 240. Or in other words, I can actually tap this power because it's 240. For now and for clear illustration, let me join them like this. Now remember, when I put this in 240, the coil here should go on and these lines should also connect so that they should light this light bulb here. So guys, let's see a moment of truth again. And yay, our light goes on. So you can see it's engaged. When I put it off, it's out. Engaged. When I put it off, it's out. Now I want to show you guys how we switch on this thing using a switch. I have a switch here. What I'm going to do, I will connect this switch. Remember, we want to switch the coil itself, so we can isolate the wires, come and strip these wires, or you can actually add another wire, but I prefer using this one for clear illustration. Remember, a switch is a series component, so you can strip your wire like this. Like this, guys. So you can actually see we have two wires. Remember, switch is series, so we wanna connect it here like this, so we can switch the line, the live conductor only. So I can come here and cut like this, then I can strip my wire like this, then I can open my switch and these are the terminal for the switch. So I'll come here, take one end and connect it here. Connect carefully for good connections. Actually, the best thing to do is to take this screw off like that. Then you can coil this conductor round. You make an eye joint like this. Then put it back here. Very carefully, very correctly, like this. Don't leave hanging strands of wire outside or you will electrocute yourself. Then bring the other end or the other joint you have cut. Then connect it to this screw here, the same. We do an eye joint. like this, and then we take it back like that. You can see my connection is clean, no hanging wires outside the switch. Then you can bring these two wires out like this. And then you can actually close your switch. Remember, don't screw any wire inside, because it can bring about short circuit or electrocution. Not okay, even if it shorts, it will just keep the bulb on, no bursting or something. But we don't want that. We want our circuit to be functional. So now if I connect my 240 volts here and operate this switch, I can actually operate this contactor. Let's see. So I can have my power there. You can see the switch is on like that. Don't know how my light is. Okay, I have not connected my light. Look this, guys, I had not connected my light, so this bulb did not light. Let's now connect my light like this carefully. Remember, when doing electrical work, never be in a hurry. So guys, now I have supplied my power for the main poles or the major terminals that goes to the bulbs, now to the bulb, and I have separate power for the coil, which I will use my switch here to operate the coil. So I can come here, put my 240 volts. You can see now the bulb is on. So when I put the switch off, the power here will be present, but the bulb will be off. Reason being, the switch will disengage and the switch will make the contact powering the bulb go off. Let's see. Remember, the power is on now here. You can switch off. You can see it's off now, on again. You see, now I'm operating the coil alone, not the major power. If you test the major power here, it's 240 or 250 volts. Let's see. You can see we have a live voltage there. We have 240 volts, but the bulb is off. So when I switch this on, I power the coil and now the bulb goes on. So this is the illustration of how this is done, guys. Next time I'll show you how you can use a one single press switch, that is press release switch, to actually operate this. And even when you release the switch, this actually stays on until you press the stop button. That is in motor controls. Thank you guys for watching me. Like my page, follow me, subscribe, and for more contents like this, let's meet tomorrow in live lessons. Thank you.